Sixth graders, here we are. We're going to do science test prep. My name's Mr. Vickery, in case you were wondering. Here's what I look like. Hello. Same format as last time. We're going to have about 60 seconds to think about and answer the questions that you see. So when I show the first question, you have 60 seconds. Teachers, remember, you can pause the video if you need more time or you'd like to throw in your own explanation. If you're ready, let's begin. You have 60 seconds starting now. All right, what do water, aluminum, redwood trees, and valley quail all have in common? That's an interesting group of things. So they must have one of these. So let's look at these statements. They are all pure elements. Well, to be a pure element, you must be made of one kind of atom. So the only thing on this list, aluminum, that fits that statement is the aluminum because it's all made of aluminum atoms. So that is not true. Water, for instance, is made up of hydrogen and oxygen. It's two things. 2 parts hydrogen, 1 part oxygen. So let's throw statement A out. B, they are all made of cells. Well, a cell is like what living things would be made out of. So I could see the valley quail and the redwood trees being made up of little cells, and you know that those look like a little circle. Here's the nucleus, and there's some organelles. That's a cell. So B is out. They are all living creatures. Well, again, I could say the valley quail and the redwood trees are alive, but the other two, I'm sorry, they're not. Let's get rid of that. Sorry, these are gone as well. They are all made out of atoms. In fact, everything is made out of atoms, whether it's aluminum, redwood trees, valley quail, or water. 60 seconds. Begin. Okay, a metal spoon was left in a pot of boiling soup. Here's the boiling soup. Here's the metal spoon. The cook burned his finger by touching the spoon. So if he touched it right here, it's going to be too hot to touch. Why did his finger get burned? Well, it turns out that as you heat the soup and all the water around is getting warmed up, that heat is being transferred directly to the spoon through conduction. Eventually it's going to make its way up to the end of the spoon, and therefore when the finger touches it, you get burned. Interesting side note, that's why you make the handle of the pot out of something besides metal, or something that doesn't conduct heat as well. Otherwise you wouldn't be able to pick it up. So the choice here is C. Next question, 60 seconds, begin. Students are gathering materials and building an electrical circuit. Which material will allow electricity to flow between the battery and the light bulb? So, in order to create a circuit, the electrons need to be able to flow throughout the material and flow through the light bulb to make it light up. When we build stuff that conducts electricity, it needs to be in a wire that's made out of metal. Wood does not conduct electricity. Cotton does not conduct electricity. Rubber does not conduct electricity. Metal generally conducts electricity, and copper is especially good at conducting. Next question. You have 60 seconds. Go! Alright, we have a diagram of an electrical circuit. Electricity is flowing in this direction through both light bulbs and back to the battery, and this makes what we call a circuit. Technically it's a series circuit, but why? It's not because there are two light bulbs. That is just stating a fact that there are two light bulbs. That is not what makes it a series. It is not the fact that it uses a single battery. All circuits have to have a battery. It could have more than one. The current is divided between the two light bulbs. In fact, no. It is going through this light bulb, then this light bulb. So series means in a row. There's two light bulbs in a row that are connected to the circuit. So the choice here is B. Next question, 60 seconds, begin. Have you ever heard of the phrase opposites attract? Let's write that down here. Well, it's true in physics as well. If we have charges, negative and positive, these are attracted to each other. Two like charges, two negatives for instance, will repel. Two positives repel. Opposites will attract. So the balloon will be attracted to the rod. Choice A. 60 seconds. Begin. The diagram below shows that the magnetic field of Earth is similar to that of a bar magnet. At which location is Earth's magnetic field the strongest? Let's look at the locations. Here's number 1, 2, 3, 4. To me, if I didn't know anything about magnets, what I could say is that 1, 2, and 3, what makes these unique from each other? And what I see is not much. They're all kind of in the middle of the Earth here. This one's maybe on the outside, but they're really all on the outside of the Earth. The one that stands out to me is number 4, and if you think about it this way, if this is the pole of the magnet, the strongest part of the pole is in the north end and the south end. So this would be the North Pole, this is the South Pole. I'm going to choose location 4, answer D. Next question, 60 seconds, begin. Alright, which of the following converts electrical energy, or electricity, into motion, or movement? We know that electricity makes things run. When we turn on the lights, or turn the light switch on, the lights come on. Turn the stove on, the stove heats up. Light bulb makes light. The only one that I can see that something's actually moving when I turn it on is the electric fan. Think about it. The fan blades will start to move the instant I flip the switch. That is motion energy, kinetic energy. the electric fan is the choice. Next question, 60 seconds, begin. When electric current flows through the metal filament of a light bulb. So within that light bulb, so if we look at a old-fashioned light bulb, let's see if I can draw one. That sort of looks like a light bulb. Within that light bulb, there's a filament that when we run electricity through it, it lights up. Do not answer, this is light energy only. What were to happen if you put your hand, this is a really bad drawing of a hand, what happens when you put your hand too close or touch a light bulb that's on? Hopefully at this point you're answering, you get burned. So a byproduct of the electrical energy going through the light bulb is heat. So light bulbs create heat and light. Therefore, the choice